Glaciers are becoming increasingly rare as the Earth warms, and their retreat is cause for major concern. They have been responsible for fantastic landforms, and some scientists have even found evidence that without periods of global glaciation, complicated lifeforms would never have evolved. With such an important place in Earth's history, it's not only fascinating, but important to learn how they form, evolve, and melt, and how these processes shape our landscapes. Fun fact! The frozen water on Earth is known as a cryosphere, and glaciers currently cover 10% of the land surface. How do glaciers form? First of all, it has to be a place with cold winters and fairly cool summers. During winter, snowfall accumulates. During summer, snow melts, but not all of it. This dense layer of remaining snow is called a firn. The next winter, more snow falls on top of the firn. Over time, the oldest ferns on the bottom are squished down by the pressure of the years of snowfall and joined together to form thick layers of ice. The weight of the ice causes the glacier to slowly travel downhill. This process results in three main zones of the glacier. The accumulation area is where more snow falls than melts each year, causing the glacier to grow. The area of equilibrium or firn line is where there is perfect balance between glacier growth and melt. The ablation zone is the area where the glacier melts faster than it grows. The glacier balance here is the time between two melt seasons, when the glacier is at its smallest. If it grows, then there is more accumulation than ablation, and if it shrinks, the opposite is true. Right now, the world's glacial balance sheets are looking too hot, or rather they are, and that's the problem. Did you know that there are warm glaciers and cold glaciers? Crazy, I know. To understand the difference between the two, we need to talk about the pressure melting point. As ice is put under increasing pressure, the temperature at which it melts changes. At the surface, the melting point is 0 degrees Celsius, but at 2000 meters, it's negative 1.6 degrees Celsius. Warm ice is below the pressure melting point at the surface, but most of the mass of ice stays at the melting point. Cold ice is mostly below the pressure melting point, even at greater depths. Glaciers can be made of one or both types of ice. Something to watch out for are crevasses. These are enormous cracks that form within the glacier created when they are moving quickly. Crevasses can be covered by a layer of snow, making it undetectable by visual examination from the surface. It's why you should never wander willy-nilly across a glacier. Scientists like to categorize glaciers into a few types. Ice fields form when the terrain is relatively flat and there are large flat expanses of ice. These are the largest and most common type of glacier. Mountain glaciers, form on mountains. There are a few types of these. Niche glaciers are small pockets of ice that hang out in low-lying areas on the coldest side of the mountain. Cirque glaciers are similar in that they are small, found in rocks shaped like this. Hanging glaciers, or ice aprons, form on steep mountain slopes like this and are often the cause of avalanches. Valley glaciers hang out in mountain valleys. When the valley glacier slides off the mountain, forming a large blob of ice on flat land, it's called a Piedmont glacier. Alternatively, if the valley glacier slides off a mountain into the ocean, it's called a tidewater glacier. Glacial erosion is responsible for creating some pretty spectacular landscapes. These are loosely categorized into residual and depositional landforms. Let's start with the residual stuff. Debris trapped in the bottom of the glacier scours the underlying rock as the ice travels over it, leaving long scores in the rock visible long after the glacier melts away entirely. Obstructions that are harder than the surrounding rock stand up to the force of the glacier and remain protruding from the land long after the ice scoured everything else away and melted off. Remember cirque glaciers? When they are gone, they leave a rounded shape with a steep slope on the uphill side. Guess what it's called? Yep, a cirque. And when two cirques meet, they create what's called an arete. Get enough of these together and you have a horn. When bits of the glacier break off, are buried, and then melt a bit later, a small round pond called a kettle lake is formed. As glaciers progress over the land, they can erode it away so that when they are gone, a glacial valley remains. They are U-shaped like this. If they end in the ocean and fill with seawater, we call them fjords. On to the depositional things. Moraines start out as long strips of debris that the glacier picks up along the way. There are medial, lateral, and terminal moraines that run down the middle, side, and end of the glacier. When the ice melts, these are left behind as ridges of rock. A famous depositional thing that glaciers do is to leave random boulders far from where they originated. Once the glacier melts, these erratic boulders can dot landscapes in the most unlikely of places. As glaciers melt, streams of icy water flow out and deposit debris at the mouth. Such debris mounts are called cames. To top it all off, Glaciers can be a contributor of superfloods. How, you ask? Glaciers can dam up waterways to form sizable lakes, but the glacier doesn't last forever, and when it gives away, it releases a torrent of water. Did this pique your interest? Please leave us questions in the comments below and subscribe for more awesome content.